Hi everyone, we're going to get started. Nice to see all of you. For those of you who I don't know, I'm Peter Youngs. I teach in the Department of Curriculum, Instruction, and Special Education. And I'm helping to coordinate the Cooper Lecture Series in 2014-15. It's my privilege in a moment to introduce today's speaker, Mark Windschitl. First, I just want to briefly give you a little background on the lecture series. It's named in honor of a former Curry dean, James Cooper, and the lecture series will focus on research and teacher preparation. Jim Cooper served as dean here from 1984 to 1994, and during that time he took on a national leadership role in the area of teacher education. He was active with the Homes Group, which was an effort to improve teacher preparation by focusing on school-university partnerships. And Jim also oversaw changes to the teacher ed programs here at Curry, including the move to a 5-year bachelor's master's program. That was one of the first such programs at the time in the nation. And in addition to Mark's visit today to the Curry School, we're going to have 3 other speakers as part of the Cooper Lecture Series this year. So we encourage you to come to some of the other talks as well. So I just want to say it's my pleasure to introduce Mark Windschitl. He's a former secondary science and mathematics teacher. He earned his Ph.D. at Iowa State, and he currently teaches science education at the University of Washington. His research focuses on how educators learn to engage in rigorous and responsive teaching over time. This is what he and colleagues would refer to as ambitious teaching. Mark's the recipient of a number of major grants from the National Science Foundation. He's widely published, including articles in the Journal of Science Education, Journal of Research and Science Teaching, American Educational Research Journal, and Teachers College Record. The title of this talk today is Identifying the Core of Effective K-12 Teaching, the heresy and promise of high leverage practices for a nation of novice educators. And he's going to speak for roughly 45 minutes, and then we'll have plenty of time for some questions, discussion. So please join me in giving Mark a warm Curry welcome.
Well, first of all, I want to thank you, Peter, for the invitation to come here to the Curry School. I've heard so much about the Curry School for all my professional career, and it's just an honor to be here. My colleagues are excited for me to be here as well. And so I would like to share my ideas with you. If anybody has a question or interjection during the presentation, I am totally fine with that. So I and my colleagues at the University of Washington have been interested in studying practice, the way teachers interact with students around the subject matter. That's a simple definition. And you can see that other people are also now interested in practice, because these books have come out in the last 4 or 5 years, and you can see some people think classroom practice is a black box. We know hardly anything about it. Other people think they know what practice is, and they're going to tell us how teaching works. I'm not being pejorative about these authors. I'm just saying, read these books. They are quite interesting. And then practices that can put your students on a path to college. So there's all kinds of contemporary conceptions about teaching practice and what it can and can't do. But we're enthusiastic about practice because we see what it can do in classrooms in ways that are transformative for students. And I'll give you an example about the impact of practice. So about 2 years ago, I went into a middle school, and our group focuses on middle school and high school science. So I went into a middle school, and there were 2 teachers teaching the same unit on solar eclipses. And I went into the first teacher's classroom, and he showed a dramatic video of shot in India about 5 years ago of the sun being completely occluded in midday, turning the landscape black. There were people in India who had gathered since the previous day, and they were waiting for this to happen. And the students thought this was so cool. They got into a conversation, and the teacher decided after a few minutes to close down the conversation. And then he said, I want you to take out your textbooks, and we're going to record some definitions of vocabulary terms. And then, a few minutes later, I went just 15 feet down the hallway to another teacher's classroom. This young woman is a first-year teacher. She's teaching from the same curriculum and the same lesson plan. But I watched a completely different practice unfold. She shows the video, and kids are all excited. A girl in one corner from Nicaragua and a boy in another corner from Turkey said, we have relatives who have seen a solar eclipse. Can we tell you about it? Now, in that moment, this teacher had things planned, but in that moment, she's got about 10 seconds to decide whether or not to let that discussion come about in the class. She made the decision, yes, I'm going to let these two students share their relatives' experiences because I can imagine how it could contribute, become a resource for our thinking as a collective. And so both of these kids start recounting the stories. And what happened was, after a few minutes, the teacher has a really good repertoire of discourse moves and has got good discourse norms in that class for whole class conversation, so that helped. But what it turned out after a few minutes was, kids came to the conclusion that people in all of the cases, the video and Nicaragua and Turkey, people knew that solar eclipse was going to happen before it actually did. So they said to the teacher, are they predictable? And why would they be predictable? Another thing they said was, this is rare. This does not happen every day. It's like legendary. If you actually saw one of these things, why is it rare? So this teacher, in that moment, made that decision spontaneously to engage in this kind of whole class discussion. That was the first half of class. In the latter half of class, she did something that she had planned, which was, can you hold up the solar eclipse little models? She gave kids the sun, the earth, and the moon, and she had them sit in groups and try to figure out, how would you create a model of that happening? Let's get our initial ideas out, and we'll see what we think. By the end of that class, the teacher had a really good understanding of what her kids understood and did not understand about solar eclipses, all of their theories. Does anybody in here have a child who's in middle school? Is a son or daughter?
A daughter.
A daughter. What's her name?
Davida?
Davida. You probably want Davida in that second classroom, because Davida would get that kind of teaching over 180 school days. That teacher teaches that way every day, and the effects aggregate over time. So this is why we're so passionate about focusing on practice. There are some popular narratives out there about teaching practice that some of us in education have to work with and sometimes work against. And one of the popular narratives out there is that practice is so situational and context specific that you cannot prescribe it. Don't waste your time trying to design practice for those reasons. There's another narrative that attaches to the first narrative, which is, if it is so improvisation, then isn't practice something that is totally personal and idiosyncratic? Another reason why we should not try to design practice. There's another narrative about trying to improve practice, which is maybe we should select the best and brightest teachers to go into the profession, and then we'll take those people on the top end of that bell curve, and they are so gifted that they probably won't need much training. That's the other narrative that's attached to that one. They won't need much training. And in fact, there's another narrative, if they don't need much training, that means they will pick up these expert-like practices on the job. Is that possible? We say at the University of Washington, not so much. And so I'm going to share with you how we came up with what we call high leverage practices, or core practices, for our teacher ed program. So I'm going to step back, or up maybe 5,000 feet, and get the broad picture of why do we care about practice, and why do we care about well-started beginners coming out of our teacher preparation programs. Well, we all know that to move the needle on student learning, there are a lot of different influences, a lot of different layers to the educational machinery: standards, curriculum, what kind of school you're in, the length of the school day, the length of the school year. All of these have an impact, but none of them have the same impact as the quality of teaching. Those in-the-moment decisions that a teacher makes actually are the lever for everything else. All of these factors work through the everyday practice of teachers. None of these can work directly on student learning. The opportunities to learn, the opportunities to reason are provided by that lever. Another reason we should care, and this goes into research on, specifically in science, why do we care about creating a different kind of novice that goes into our classrooms and can do this kind of transformative teaching, is that over the last 30 years, we've found out an enormous amount about what young kids are capable of in terms of science. Similar findings are there in math and history. What can children do that we didn't know that they could do 20 and 30 years ago? They can think with and about abstractions, even at a young age. They can design experiments and even control for extraneous variables. They can construct scientific models and revise those on the basis of evidence. They can construct theories and engage in arguments about those theories. They can even monitor their own progress towards deep understanding. And when I tell audiences this, a lot of people usually say, yeah, I know some high school students who are able to do all those things. And then I remind the audience, these findings are all from middle elementary and upper elementary students. All the studies show. So we are greatly undershooting with traditional forms of instruction. We are undershooting what kids are capable of in science. Now, the other side of the coin is, what is typical teaching like? And I do not mean to be such a heavy hand on teachers here. I am a teacher myself. I was a teacher. I still am. But these are the data about common forms of science teaching in America. Typical teaching, in these findings come only from studies in which people actually went into classrooms to do observations, or they used video. There's no self-report data here. So, in general, from these large-scale studies, classrooms are well organized in American science and math classrooms. Kids feel their ideas are respected. Kids know what the objective of the lesson is generally. Those are all very positive things. However, there are some issues. In general, there's a lack of intellectual engagement in science classrooms and in math classrooms. And part of that reason is that teachers don't often, American teachers more than any other country in the world that's been studied in national comparison tests, focus on activity, but they engage kids in hands-on activity without doing the sense-making talk that allows them to make something out of the activity they just done. The other thing American science teachers struggle to do is organize entire units around really big ideas in science. Student ideas, and this goes back to the solar eclipse example, students' ideas are not used as resources. When a student asks a question, typically in a classroom, the teacher takes that as a request for information and answers it, and then moves on with the lesson. But ideas or questions that kids have aren't used as resources, and there is, going along with that, there's no way of challenging ideas, either scientific ideas or students' ideas. And questioning and discourse is some of the weakest aspects of classroom practice. It's not a great picture, but this is where we are and what we're going to work on. There is, in fact, a kind of conservatism in American science teaching that has persisted over the course of at least 40 years, a kind of dynamic conservatism, to borrow Donald Schoen's term. And that means that there are always changes going on in classrooms. Every round of reform, there is either technology being added to the classroom or group work or more hands-on activity. But under the surface, I'm using Larry Cuban's surface versus below the ocean metaphor. On the surface, there's a lot of change. Under the surface, this basic infrastructure here still holds in classrooms. Kids are using iPads, but it's still delivering information from somebody. Didn't somebody over here Google? Tell them what you did with the solar eclipse challenge I gave you before we started.
Neither of us had our phones with us, but
I didn't know it was an activity. I apologize. But yeah, after we had an idea, we confirmed it with Google.
Did you hear that? They looked it up on Google. So technology doesn't always help. But anyway, this basic structure is present in still present in a lot of science classrooms. So our challenge is to prepare. Again, I'm drawing back to our work at the University of Washington. We are not just trying to prepare teachers, we are thinking about, in the process, shifting science teaching and what it means to be a good science teacher. And there are a lot of reasons why this is not gaining a lot of traction, or hasn't over the last 40 years. And I'm only going to cite one reason. There are a lot of them, but one of the reasons is that no one has ever characterized what it is that teachers do in terms of a technical core. Now, Dan Lordy was the first one to bring this up back in the 70s. He was saying that medicine, aviation, law, architecture all have these very common practices, and people know what they are. They share a common language around those. But teaching has none of that. It's a very isolating profession, and we don't share practices. and therefore we cannot advance them. Now, more recently, Tony Bright from the Carnegie Foundation has invoked the same idea that he's thinking about developing a technical core or a common set of well-known practices for teachers that can be used to develop social and pedagogical capital among communities of teachers, not just individual teachers, but communities that share and innovate on ideas. So the importance of a technical core is not just, here's how we teach, that's not all it at all. It's, here's the basis upon which we can innovate in the future. So I'll give you some specific examples here. So here's where that heresy, in my title, remember I used the word heresy, so here's where the heresy comes in. We believe in our, not just in our group, but there's a number of teachers across the country who are starting to think about core practices in their various disciplinary areas. We think that there are not only some practices that are more important for beginners to learn than others because they move the needle on student learning, or they can help more students participate, more different kinds of students participate. We know that there are some practices that do that better than others. The heretical part to some people may be that we think some are so important that they should become the focus of teacher preparation. In fact, we've actually made them the focus of in-service professional development for teachers. And so at the University of Washington, our group has picked four. We only have 4 sets of practices. Really, there's 3 practices within each of these on the diagram. We drew these practices from a synthesis of the research on student learning. We also looked at expert teaching. We also looked at what it meant to teach science as a discipline. And then we also looked at the equity literature. And we tried to pull those together into and select and sometimes generate practices that would make sense to teach in a classroom for beginners. It's teachable by us and it's learnable by beginners, even though these are complex and some would say advanced practices. So they fall into 4 categories. The first one is planning for engagement with important science ideas. The only thing I'll say about that is we have found that unless our teachers, either beginning teachers or in-service teachers, unless they plan intentionally for a unit of instruction around big ideas, all the rest of their attempts to engage in what we would call ambitious teaching, it breaks down. So you have to be able to plan unit-length experiences for kids, talking 2 to 4 weeks or so. That has to be intentionally planned. And so we actually have a practice, and we have a set of tools around being planful about that. The other 3 are practices you see happening in classrooms. So eliciting students' ideas is the practice I described with the solar eclipse. Teacher at the end of that period understood like 5 or 6 really different theories about how kids were thinking about solar eclipses, including in that class about 20% of students thought that a solar eclipse happened because the clouds passed between the Earth and the Sun. So this next practice here, supporting ongoing changes in student thinking, this would be a cluster of 3 practices that you'd engage in multiple times over the course of a unit. This is like once every 3 or 4 days. You engage kids in an activity and the sense-making talk around that activity, and then after they have made sense of that activity, you go back to the biggest ideas of the unit and say, now that we've understood this, how does that help you rethink the larger picture, the larger problem in the unit? And then the 4th practice here is pressing for evidence-based explanations. This you almost never see in classrooms. In fact, we have data that shows we have never seen it. In one of our studies, we found 0 examples of first-year teachers who were able to get their kids to use more than one investigation to develop an explanation for a complex event. I'll share some more details about that. But that 4th practice means you take more than one set of ideas in order to put together for an evidence-based explanation. Now, if you go into our graduates' classrooms, you will see similarities in their performances. You probably won't just see this and this and this going on. You probably will see some of the things on the right. These are also characteristic of ambitious practice. One of the things you'll see is that there are records of students evolving ideas on the walls. So in the solar eclipse classroom, as soon as the unit gets underway, there will be diagrams of kids' ideas of how the solar eclipse actually happened. They may not be correct, they may be partial, but they're on the walls and they're identifiable, and kids can go up and compare, who's thinking what. There's also varied opportunities for student talk, not just with the teacher, but with each other. And going along with that, teachers don't just ask students to talk, they provide sentence frames, sentence starters, they provide norms, they provide scaffolding also for writing, because writing in science is really critical, and kids do not know how to write in a disciplinary way. There's also scaffolding for participation in small groups. This is something you would see in these classrooms. They have a kind of family resemblance, and of course there's the press for evidence-based explanation. So in our teacher prep program, we need to choose representations of these various practices, and we have to combine them in a way that's powerful for beginning learners. So one of the things that we have accumulated is a whole library of teachers actually doing this work. When we first started, we had no videos, and it was really rough on our beginning teachers not to see images of teachers doing this. And now we have over 90 videos in our libraries, and every one of them is in a high needs classroom. Because you know how teachers often watch video, they think that's not like my classroom, so it helps to have classrooms that are diverse. They're high needs schools, and the wonderful kids that are in those schools, those enthusiastic kids, it's good to see that on video. We also have student artifacts that go along with the video of what the teacher is doing. Another thing that we share with them is we actually have a tool that describes an actual practice. And embedded in this is not the tool, but this is inside the tool. So it's a written document, but it has, because we think that talk is so vital to ambitious teaching, you have to be facile with talk and with discourse in the classroom. And the only way to do that is to help them understand how talk can happen and where the different kinds of discourse moves you can make. So one of the first things we do in the program is our students read a discourse primer. And it's just something we wrote that acquaints students with what is talk. Like what are moves like revoicing, pressing, probing? How do you use wait time? How do you endure silence in the classroom? How do you use turn and talk? And we developed something with another university called A-B Talk that helps two students, one of whom is an English language learner. So our beginners have this toolbox of discourse moves, which helps enormously in every single practice that they do. And we also then represent the practice live. So I have to model all these practices, and it really makes me nervous because I have to do a good job. And so I model it, they act as students, and then we have them choose a small bit of the practice to do themselves, and they rehearse it, and they rehearse it, their own peers, and I act as students. And primarily all these practices are interacting with our ideas, so we videotape them and ask them, how did you interact with our ideas over the course of that 20 minutes you had? So these are all the different ways we represent practice to them. And this is just in one quarter. We have them a second quarter, and we expose them to different and more complex forms of representations of these practices then, but in the interest of time, I'm going to talk about what we do there. I think this gives you a good understanding of their initial quarter. So I want to show you, oh yes?
How long does it take to implement the discourse tools in the class? Like for example, like 4th or 5th graders, is it kind of a new thing for them?
It is really new, right? Yeah, so before they come to me, they've already been in a classroom for about a month. And when I ask them, tell me what's going on in your classroom, they'll say, kids were doing this activity, the teacher did this. But then in the very first class period that I have with them, I give them for homework this discourse primer. It's available on our website, anybody can have it, but it's like a 10-page document and it has all those discourse moves in it and principles about talk. And from that point on, after they read that and discuss it, the very next time we gather as a group and I say, tell me now about what you see in your classroom, they all immediately pick up the lens of discourse. They will, instead of the teacher doing this or that, they will say, the teacher was talking in this way, high cognitive demand questions, or nothing but low cognitive demand. And my teacher gave them no wait time. The kids were interacting with themselves without direction by the teacher. They were talking to each other. So the emphasis, almost immediately, Rarely in education do I ever see something that is so successful as that discourse primer. I mean, it's like, it really works. I don't know if I answered your question.
No, that's right.
Okay.
Yeah.
Okay. So what I want you to see here is what the effect on a community of teachers is when you share some vision about ambitious practice. And so I picked 3 teachers who are not in pre-service, but they're in their early career stages, and they are all graduates of our program. And I purposely picked a kindergarten teacher. We did not originally design these ambitious practices for kindergarten, but lo and behold, we had 3 or 4 kindergarten teachers in our doc program who were so interested, they said, can we try to do some of these practices? And they're able to do it. So I'm including Michelle here. So the practice that you're going to see, and I apologize, these clips are very short, and I'm going to have to talk over them because the audio is just not, optimal. But what you'll see is a family resemblance. They're all doing the practice that's called supporting ongoing changes in student thinking. So the part that you will see in these videos is you'll see the kids are doing some activity. But the important thing is that after the activity, the teacher does sense making with them and uses a public representation of kids' ideas. And these are physical, inscriptions, drawings, writing on the wall, poster papers. But they're changing. The idea is the teacher interacts with kids' ideas. I should have backed up and said that. The big overarching thing of what you do in ambitious teaching is your job in the classroom is to work on and with kids' ideas over time. You are there to help them reconstruct their ideas. That's what you're there for. So you will see that family resemblance. I hope you can see it across these 3 examples. Michelle's teaching in kindergarten. Her big idea for the unit is how can something little push something big on the playground? She had her kids draw a slide because she modeled this. She had her daughter sitting on top of the slide. Her daughter comes down and pushes her, Michelle, off the end of the slide. She videotapes that. And so it's a unit on force and motion. And actually explaining this using force and motion is challenging. So that's kindergarten. Here are the kids' initial models. Anna at the 7th grade is trying to help kids understand how phase change happens. Solids turn into liquids, turn into gases, and back to liquids. And what Anna did was she had a flask filled with Coca-Cola, because kids understand a lot about pop, soda pop. Took Coca-Cola, had a flask, boiled that flask off, boiled the flask, and then there was a tube going to another empty flask, and what boils off is just the water. And the water ends up dripping over here. So what you have is kids need to explain on a molecular level how can this be that you have Coca-Cola over here and you have pure water over here. And at the end of a few minutes, you're left with nothing but like crystallized sugar, 14 tablespoons worth of sugar, right? Bethany, I don't know if I'll have time to show Bethany, but Bethany is teaching ecosystem dynamics. And this little graph here is the population of a hare or a rabbit in the northern forests of Canada. And what's weird about their population is it goes up and down really regularly, like every 11 years. And that's the puzzle kids are trying to solve over the course of a unit of instruction. So I'm going to see if I can get that started. And I apologize because I'm going to end up talking over this. For some of it, there's no sound. This is Anna walking around with, you see the clear water in the windows and the Coca-Cola in the top left.
Casey asked this question the other day. She went to start.
Oh, sorry. So Anna has just shown that. Now class is the second half of class. Or sorry, this is a day later. One of the girls was interested in this idea about evaporation and condensation, and she comes up to Anna. In the previous day, she comes up to Anna and she says, I got this cup at Starbucks, and I filled it with ice water, and it was dry on the outside. But then after a few minutes, water starts dripping down on the outside, and I didn't let any water out. And so Anna says, I'm going to use this student's experience as a resource. She recognizes that it's possible, and she imagines how that's possible, so she brings it in, and this becomes the next day's activity. So she's talking about a girl who has a Starbucks cup, and she tries to simulate what's happening. She'll give kids a jar that's filled with red fluid, and it's got an ice cube in the middle of it. It's all red on the inside, and it's a jar that's sealed tight. And so no water can get in or out. And yet, there is moisture that appears on the outside of that jar. And it's amazing to hear how kids argue that that moisture can still come from the inside. And so she's doing sense-making talk with a small group of students here in a moment. So that's what you're seeing.
She got an ice drink because she's lucky. Okay? She set it down on the table, and a few minutes later, she realized that the outside of the cup had water on it, and then there was a puddle forming on the table. Okay, so her question was, where'd that water come from? How'd it get there? So this is like the best example of an idea question that I can give you. Something that your classmate asked that we want to just share our ideas about. Then we're going to learn some stuff, and we're going to come back to this question and see if we figured it out or not.
So where did the water come from?
It had a hole.
It had a hole. So from inside?
Yeah, inside.
Yeah, but how did it get out?
Condensation.
What is condensation?
So let me stop it there. So you can see this young boy using the word condensation as a way to get out of having to explain the benefits. So Anna's not going to allow that. So in a couple minutes, here's the public representation piece. Anna has put up 2 posters, and one of them says, are there really gas molecules floating around in the air? Are there really molecules, maybe water molecules floating around in the air? Yes or no? And where did the water from Stacy's Starbucks cup come from? The inside or the outside? Kids have to take a little post-it note, talk to a partner on which one they think is true here, which one they think is true here. They got to put it on there, and they have to write a little explanation of why they think that is the case. So, I'm sorry, yes, go ahead.
I think a lot of us maybe have experience where students are afraid to give what
Oh,
we
you got it,
consider.
right.
Oh. I think sometimes we've seen students are afraid to give what they would consider to be a wrong answer. So how do you get past that barrier of students not wanting to make their ideas public?
Anna does a lot of norming with her students on the first few days of the school year. In fact, she has a room that's smaller than this, of course, but what she'll do is she teaches on that half of the room. She has sequestered about 10 square feet in the back of the room that she calls her idea space. And that's a safe space. And she draws kids, gets them to stand up, go over to the idea space, sit down, and she says, now we're going to talk about your ideas, and any of your ideas are worth talking about. So, do you have a hypothesis? Do you have a question? We're going to put them up here. So she tries to enculturate them into the idea that everyone's ideas are worth listening to. But it's not easy. This is only the second week of the school year. So she has already normed them into this. She does norming into routines, both procedural routines and routines about like feeling safe with one another. She does that norming really quickly.
Yes or no? Henry's going to make a guess, and I'm going to say yes or no. So what we're going to do now is we're going to try to give you some more information so that you can revise your ideas if you need to. But we're still talking about your ideas. Is this water on the outside that I feel feels wet? Is that coming from inside the jar? How do you know that?
Because you said if it comes from the inside of your
Say that out loud.
it's not 100%.
So how can you explain that it's not red if it's coming from the inside, the water inside?
Because the water
Okay, so I want to stop this here. I'm sorry to keep stopping it, but so Anna, this is a part of the sense-making practice. Anna visits class small groups. She always has small groups. She visits each small group. And there's some procedural parts of this practice. She gets down on one knee or sits because she has to be at the same head height as her kids and not looming over them. And she engaged this first young man here to talk about where do you think that moisture came from. He said something, and then she knew that this girl that's sitting right here is very shy and very quiet. And she used a very discreet move. She simply turned at her eye gaze at the student and asked directly at that student, which gives her, that young girl, permission to talk. Otherwise, she would not have said anything. And she was so quiet, I had to I had to put subtitles in about what she said. Anyway, let me finish this.
It's clear.
Exactly, it's coming from the outside.
Answer this question one more time, but this time I would like you to include the jar in front of you as evidence. I want you to look at this question. Whoa, what a shift. We have a huge shift. Look at where all those blue post-its are. We still have people that disagree.
So that was, I just wanted to show you there, she is just having them revise their thinking, and all the blue post-it notes appeared on one side. That was after they had that experience. All the orange post-it notes are pre the little activity they did, so they changed their thinking, and she's now going to ask them, why did you change? You switched your post-it note. Why did you do that? So all that talk comes out in this practice. So I'm just going to show you the kindergarten. I won't show the high school. So in the kindergarten, the activity that the kids are going to do is they're rolling a ball down a ramp that pushes a cup to simulate the slide activity where the young girl worked down a slide and pushed the teacher off. So it's kind of a modeling of that activity. So the kids are going to engage in that activity, and then the teacher is going to engage in scientific modeling. But how do you do that at the kindergarten level? So I'll show you how she does it.
Now you can measure it. Okay, you guys measure this one? Okay, so it looks like the bigger ball pushed the cup farther, but that's not the end of the story, you guys. Are you ready to be scientists? Okay, I'm gonna write this in. It says the blank ball pushed the cup farther because it has more strength, more force.
So this is the part that's actually interesting. So the kids' diagrams of all their experiences are over here. And what they thought about that ball going down the ramp, it's all there. She has strategically placed that next to a model of the actual slide. And now she engages in scientific modeling with the kids by having kids put the labels for the words that they think relate to force on different parts of the slide.
Who can come and tell me which science word they think would go on that first red dot? Logan, what do you think? It goes there. Push. Hold. Nice.
Yep.
What? Why does he have so many pushes and pulls? So it goes, does it go all the way up? Logan, can you tell me why you do that?
Push,
Pull all the way up. Is that a new idea? Yes. Where is gravity? Where does it happen? Show me.
You repeat it.
Oh, good. Okay, so tell me why you put it down there. You can leave it. It's hard to. Okay, good.
Because it pulls everybody down so they don't get rolled up.
You're right. It's a new idea. Good job. Okay.
So Michelle has a model of the slide. She really didn't expect kids to put the push-pull on the ladder itself. She thought they were going to put push and pull at the top of the slide and at the bottom. But the young boy thinks pushing and pulling happens actually before you can get up there, because you pull with your hands and then you push up with your feet. Michelle, the teacher, had no idea that that was going to happen, but here it is. It's modeling, scientific modeling. They're changing their thinking. Okay. I'm going to... Sorry, I'm working on two different screens here. There we go. Okay, so I saved this until after we saw those video examples, because otherwise this wouldn't have made much sense. You might ask the question, what do we count as a practice? So we use social practice theory, and what counts for us as a practice is it's any work devoted to planning, enactment, and reflection intended to support student learning. But it has to have these four things. It has to have a goal. So if you think that you engage in a teaching practice, see if this fits. your own practice. It has a goal. It has a prototypical sequence of interaction with learners. It's not like a script. It's not a network, but there's a backbone. There's a similarity in what comes first, second, and third. And what comes first, second, and third is there for a reason. There are characteristic talk tasks and tools that are associated with that practice. And then there are underlying principles that allow variations of the practice. This is super important for us. Because again, we're not talking about scripts. We are talking about teachers who innovate on a basic framework of a particular practice. And if you innovate, you can innovate on this, you can innovate this, but you cannot change that, and you can't change the underlying principles, otherwise you're not doing that core practice. So one of the principles for the 2 videos you just saw was teaching students ideas have to be made visible and public. If you don't make that thinking visible and public, then you kind of violated this and you're not doing that particular core practice. So I just want to end by sharing a comparative study. We had 2 groups of teachers. We had 2 cohorts of teachers from 32 teachers from our own program who had benefit of experience with core practices. And then we had a comparison cohort of 13 teachers, all secondary science, who came from other programs but who were matched to our folks on several key criteria. We followed them through their first year of teaching. We did case studies on all of them. So there's a rich history on each one of these individuals. We used observations 3 times a year, student artifacts, and interviews. And we observed them on these 4 criteria, all related to ambitious teaching in general, like how teachers use big ideas as a focus of instruction, the degree to which they elicited and then used students' ideas for the class, how teachers supported sense-making, and how they supported evidence-based explanations. So here is, let me explain this graph. So this is just the comparison cohort. This is a group of 13 who have not been through the core practices regimen. And level 1, 2, and 3, this is how they use big ideas as a focus of instruction. Here is what a level 3 would be. Unit designed around a natural phenomena that's complex and represented throughout as a model that's supposed to be critiqued and revised over time. If that's what we observed, then that observation would go to level 3, that'd be rated that. The vertical axis here is the percent of observations made at that level. So these 3 bars should add up to 100%. So as you can see, in the comparison cohort, there were very few observations, like less than 1% of units that were designed around a natural phenomena and represented as a model that should change over time. The vast majority, there were no big ideas at all. Here's a distribution for the core cohorts. And they, of course, have a different distribution. But here's where you can see that we have fully a third of our people who have been through a year, an intensive year with us. A third of our people still conducted units with no big ideas. This is the second kind of criteria we use. Did they elicit and build on students' ideas? Here is what would get you to a level 3. You'd be rated here if you did that. And what you see in the comparison cohort is largely about 80-some% did not elicit students' ideas in any way, shape, or form. If they elicited them at all, we gave them credit for level 2. The core cohort, by contrast, has, again, a different distribution, but fully a third of our folks, after all this intensive work, still are not eliciting kids' ideas at all. This is a third out of 4 practices supporting sense-making during activities. There's 4 levels to this, and this describes the most sophisticated level. That looks like a hole that you can put your finger down. It is a hole because it's 0. We had 0 observations in the comparison cohort that fit that description. And that's not that different than those large observational studies of experienced teachers, that there's a lack of sense-making going on in association with activity that kids do. The core cohorts had a much different distribution, and again, too many people down here, but there is a whole number of individuals here, and this tells me that people can do it. People can can actually do these things in a classroom. If that would have been 0 by our whole cohort, I would have rethought that practice entirely, because if it's unachievable, I got to rethink whether that's doable. Yes?
In your studies, I'm sorry, was there a qualitative element to that part where you had the why? They said that they didn't do that?
Qualitative element.
Well, I mean, was there a lot? Did you ask them why they weren't having big ideas? Or, I mean, because I'm suspecting it was because of time and curriculum, they felt they didn't have time
They
to let
felt,
kids explore.
yes, we had about a third of our teachers from our cohort who would go into schools, and the school context just kind of ate them alive. They got pressure from their peers to stay on a pacing guide that was given to them by the district, and they had no time for sense making. Yeah. So about a third of our teachers really got kind of swallowed into a culture of content coverage, I would say.
Do all of these have, for example, they're a level 1 for this one, would they also, did your studies find that they're also level 1 for the other categories as well?
Are the same people?
Yeah, for example, they remain on level 1 for the big picture, and then they're level 1 for support sense making.
That's a good question, because if you remember, I said teachers that we have studied, we studied like 80 teachers in a previous study. Those teachers out of that 80 who could not design big ideas into a unit in a planning process, all the rest of their attempts at practices like this would falter. And so I don't know if these ratings are independent of their lack of ability to construct an intentional unit based on big science ideas. I don't know if these are independent of that planning practice. And last of the 4, the press for evidence-based explanations. Here's a description of what would get you a rating of 4, and you can see that little hole you can put your finger down into. That means no observations there at all. And level 1 is there's no press at all. Look at, there's 65% of observations. There is no press for kids to explain anything. And then this is a little bit better, a different kind of curve. So just to sum up, ambitious teaching, we think ambitious teaching, especially if couched in terms of visible practices, that ambitious teaching is teachable and it's learnable. But we do have, in these cohorts that we train so intensively, we still have a fallout of 1/3, 1/3, 1/3, which means about 1/3 of our folks can go into schools and take up some beginner's form of these ambitious practices on a regular basis. This other third, they go into schools, and if we go visit them, there is no trace that they came from our program. After all the work we've done, after all the video they watched, no trace that they came from our program. And then these interesting people in the middle, we call them compartmentalizers, because these people really are attracted to the idea of ambitious teaching, and what they do is they try to take a piece of it outside of the rest of the instructional context, and they just try out pieces of it. And it's not always successful because they pull out pieces and don't support that piece with other parts of the practice. But they continue to work. They continue to work on it. So last slide here, what we think we know is that novices can learn from one another's attempts at ambitious practice. Because everybody shares some vision of what these 4 practices are about, they can talk to each other. They can show examples of how they did that practice, and when they see other people showing examples, they can say, oh, you could have done this, or I did this during that practice, or here's a tool I used. Knowledge, in some ways, among a lot of our community, and now we've got like 8 or 10 cohorts of these beginning teachers out there, knowledge has become a kind of social capital. We are able to build like pedagogical capital among this community of teachers who shares this language around ambitious teaching. It's not perfect, but it's better than it used to be before we had these 4 practices. And then the last point there is, it would be naive to think that teacher education could achieve ambitious goals to shift teaching all by itself. That's impossible. There are other parts of the system that absolutely have to change, including things like doctoral preparation and things that are embedded in schools, like how do principals evaluate our teachers? I really do want to know how an assistant principal comes in and sits in the back of the room when my teacher has let those 2 kids, one from Turkey and one from Nicaragua, talk about their solar eclipse, their relatives' experience of the solar eclipse. I wonder what that assistant principal is writing. I didn't plan to tie this back to the first thing I said, but it worked out nice. And I'll stop with that.
Thank you, Mark. We actually have some time for questions and discussion, and we will ask folks to speak up to the microphones.
So I have a question about your previous slide, the 1/3 and 1/3. And I guess I want to kind of provide a context. So teaching is a risk-taking event. And you think about the risk that if it wasn't observable, does it mean that your teacher didn't learn or pick up that skill? It might mean that they may not have been willing to take the risk.
Yeah.
And what types of structures do you provide where your teacher, that 1/3 who's going to take that risk? Whereas the bottom 1/3, they may know it, but they're just not willing to take the risk. And how do we create structures for them to be willing to take those risks?
Yeah, it's another version of your question is, are we, by taking this data, are we testing whether they can do ambitious teaching or will they do it?
Right.
Those are two different questions, which are, we cannot distinguish that here. We cannot tell. We have to be pretty, we have to moderate the claims that we can make based on that notion. But yeah, I don't know if there's a sufficient way to support the people in the 1/3 that does none of this ambitious practice. Part of the reason I know that the 1/3 who does none of this ambitious practice, one thing they have in common is that they struggle throughout the program to talk about kids' thinking and to imagine how a kid would reason about the solar eclipse or reason about fractions or reason about democracy. I know that most of that 1/3 struggles with that, and I'm wondering if that's one of the underlying linchpins for whether or not people...
Is that a content knowledge issue?
That's another thing that, yeah. Yeah.
I'm still wondering about that 1/3 of the lower teachers, the ones that are not being able to move to the higher, more effective practices.
This middle group?
No, the lower one, or in the middle one too. So those two groups, how do you get them to move to the higher group? Do you think, is it a dosage thing, or is it more like underlying other factors that could be affecting like their beliefs or like their own content knowledge, as we were just saying? Is something you think could be changed with more intensive training? Or
it's hard to imagine more intensive enculturation into those practices that we get in our program. A lot of the people who don't do ambitious practice at all, they are actually afraid not to use the language of ambitious practice around us. They want to keep using that language. They want to be part of the group, but they're not going to actually do it in schools. We have found no association between content knowledge and people's ability to take up ambitious practice, except to say that people without a certain base level of content knowledge, they cannot do ambitious teaching. There is no way they can do ambitious teaching. But once you get up in the mid-range of content knowledge, between the mid-range of content knowledge, which is sufficient, and Ph.D. level understandings, which I have every year, at least a couple Ph.D. folks in my class who want to go into teaching, I find no correlation at all between successful teaching in the class and that level of content knowledge. When you get beyond that bottom quartile or so.
So I guess my question is there hope for that group?
There's always hope, and we include everybody back. We have professional development. We say, everybody, please come back. But they all do. They all come back.
But then again, so it might be something of dosage or maybe like repetitive dosage after a period of time where they've been trying.
We're wondering whether it's a case of dosage and the accumulated aggregation of experiences by these teachers is going to cause them sometime to just shift, or is it a critical incident thing where we have to provide some experience for them that just shakes their view, their stance on teaching and learning, and causes them to do this big turnabout. So we don't know which of those two we should use, but we keep trying. We keep contact with them, and so I hope it's a good answer. Jim, are you going to ask me a hard question? Are you going to ask me a statistical question?
No, it's not going to be a hard question, but it is going to. It is going to be sort of the economist follow-up to this question, and it is. So it's the opportunity cost. You guys are investing enormous time and energy in doing this. They don't get it. It could be that you could be spending that time on a different group of people and getting a much better outcome. And so, is there a way of trying to diagnose early on in the process that who's going to end up in that bottom third, and maybe not admit those people to your teacher preparation program, and instead focus all that time and energy on a group of people who are going to be in that top third?
Yeah, it is hard to do that diagnosis. We've talked about that in the program. Can we find out whether people are at all interested in the entering interview? Can we get them to talk about students' ideas? We're thinking about showing them videos of a teacher and a group of students having a conversation and saying, tell me about the students' ideas and what are they saying? We've actually done that in some of our interviews, and it's remarkable. We have had candidates trying to get into our teacher ed program who do not mention the students at all. They will talk about what the teacher's doing. And then I say, a follow-up, I stop and I say, no, you told me what the teacher is doing. Now, I really want to know what you think about the students. They continue to talk, and they cannot talk about students. And then we don't let them into the program. But it's not always that clear cut. It is really hard to tell through any diagnostic pre-procedure. But that would be one thing you could look for. It's hard to turn them away because they have strong social justice orientation. They're willing to learn. And I would hate not to see those people part of our teacher corps. These people are not ambitious, but they are actually pretty good traditional teachers. They're organized. They present information in an enthusiastic way. They pay attention to kids' misconceptions and try to correct them. So they're good traditional teachers. But they have a completely different stance towards teaching. So I know you've had your hand up for a while. Sorry.
Well, I don't have such a hard question as James, but I have a couple questions. One is the middle third, in that they may have looked like the lower third originally, but maybe you disrupted some of their practices, but you haven't gotten them to the top third. And I'm wondering if you consider the outcomes of these three groups, if you would say they're probably going to have kids who are going to have better science learning or worse science learning than the lowest group. So you have the middle third, where it's like you've taught them a set of practices, they've taken parts of it, but not all of it. And it's sort of like they're half implementers. You know, they're implementing halfway, whereas the bottom third is like, well, they're not implementing, but they're doing very traditional teaching in a high quality way.
Yeah.
So of those two, would you say one group might have better outcomes, or their kids might have better outcomes in science?
I would say they probably have equal outcomes because these people are good traditional teachers. These people are really traditional teaching, like 75% of their teaching you'd see as traditional, but they throw in 1/4 of what they do is a chunk of a practice that's taken out of the rest of its context. Like they'll have kids do a public representation of their thinking, but then they won't refer to it ever during the lesson. They just put it up on the wall and think kids will learn just from that. They don't include the talk and the dialogue about it that goes along with it.
And that actually fits with the exact question that I was going to ask before Jim asked his interesting question, which is about this phase of supporting the ongoing thinking. So when you described it, it can occur over 2 to 3 days, right? That you were describing. So I'm curious because for those 2 or 3 days, it's really ambiguous in the kids' minds about what is the correct answer that has evidence behind it. So for a few days, the kids are in this kind of questioning, trying to understand phase. Now I'm thinking about other things I've read or heard teachers say about that. And one teacher, for example, saying you never want to write something that's incorrect. Never want to have kids write something that's incorrect because that's what they'll remember. Or another person saying, well, if they don't understand for too long, they just give up. And so I'm just curious about how you maintain the energy and the interest, and then bring that home to go from the supporting thinking to actually, okay, there's evidence for this answer, without losing the energy and then ultimately kids being left in a confused state.
Okay, so you've asked us several questions. They're all hard ones. Like teachers, when they see these videos, they think, no, shouldn't you tell them the correct answer? Aren't they going to walk out of the classroom without the correct answer? Well, imagine remember the poster board she had, where you could decide whether the water on the outside of that Starbucks cup, whether that water came from inside the cup or outside the cup. Now, kids walked up there and put down stickies on both sides of the poster. Some clearly mistaken that it doesn't come from inside the cup, but you have more than half of the kids put that poster note there. Now, when you start discussing the reasoning behind that, and you do that activity, and it gives you a chance to change your thinking. You saw how many kids changed their thinking during the course of that period. It's an illusion for us to think that if Anna would have just stood up and told them at the beginning of the period, that water comes from condensation from the outside air. It's an illusion for us to think that all those kids would have walked out of the classroom fully comprehending what that means. So I always say when you're talking in the classroom about ideas that have partial correctness, you have to compare that against the traditional mode of teaching where you just tell kids like answers, and the illusion that since you've said it, they fully understand it. So as far as keeping kids engaged over the course of 3 weeks, when they're picking away at different parts of the problem, the kids are really invested in understanding how Coca-Cola can be distilled into pure water. And every day they feel like they're making a little bit of progress because Anna only tries to teach one important but a small part of that idea every couple days. And they feel they're making a little progress towards a full evidence-based explanation. So an idea in her room is not correct or incorrect. An idea is more consistent with evidence or less consistent with evidence. She doesn't use correct, the word correct, very often purposely. It's more and less consistent with evidence. Makes a big difference in how the kids think. Framing issue. Yes. Oh, sorry. Some people here have had their hands up for so long.
Thanks. Thanks for your presentation. We've been talking about the thirds as individual capability. You mentioned in third earlier that were eaten by the schools that they were working in. I'm wondering how you make sense of that. Are there individuals who go through your program who are in those same schools but aren't eaten by the system? Do you do anything to help make teachers more resilient to face the kinds of devouring system that they might face?
We have a number of teachers in the upper 1/3 who consistently do ambitious practice. They're in high-need schools where there's pressure to conform to their other more experienced peers and just keeping up and covering content. But they somehow resist that. I don't know how they do it. They're just brave and they're resilient and they're willing to risk friction with their colleagues even though they are novices in the school. They have rationale for what they do. I mean, some of them in the top, I call them the top third, but third that does ambitious teaching, they're also pretty good at sitting down with their colleagues and saying, here's what I'm doing, and here's why. Or they nudge their colleagues and say, this is your unit, where is your big idea? I don't think you have a big idea. We should try this. And then they start actually influencing their colleagues. And their colleagues will, without training, they will take up some parts of ambitious teaching, like an emphasis on talk, and putting big ideas into the unit. Because they walk into the classrooms of the novices and they look on the walls. That's one thing that differentiates the ambitious teachers, is their walls are full of like norms and talk strategies for how to get kids to participate in whole class talk. And their colleagues come in the room and they say, what's that for? And they said, that helps my shy students participate in a conversation in full class. We have sentence frames for how to civilly disagree with your fellow students' comment. And so that gives permission for quiet people inexperienced in a whole class talk or kids from different cultures to say, I'm going to use that sentence frame as a way to begin my critique of your idea. And their colleagues say, boy, I'm going to try this out. And inevitably, those sentence frames work marvelously that way. So once again, I've evaded a direct response to your answer, but hopefully I've given some interesting information.
As I listen to you describe ambitious teaching in science, there's so many overlaps with math education in terms of tools, tasks, and talk. I use a lot of this in can. Do you work with your colleagues in math education, or do you guys at the University of Washington kind of have some overlying ideas that match all the content areas and that get taught throughout?
We're an unusual university, so Julie knows all about this. At the UW, we're unusual because we have so many people in different content areas. We're so invested in teacher education. And one of my colleagues, Elham Kazemi, in elementary mathematics, she also uses core practices, and our elementary folks do too. But eight or 9 years ago, my colleagues in science in our research group, we thought that we had come up with core practices. We had never heard the term. And somebody said, Elham said, you should read some of the math literature. And then we read the math literature, and here is the work of Maggie Lampert, Deborah Paul, Elham, Megan Franke around core practices. And we said, they are doing what we are doing. We have like converged on this imperative to really focus on practice that's really rich, that teachers can innovate on. So, did I answer your question?
Yeah. So you have a framework for your elementary teachers that teaches some of these core things as well.
Yeah, Elham Kazemi has a different set of core practices than we do. Hers are not generalizable across grade levels or across subject matter. The math folks have specific practices like choral counting in elementary. That's one of their core practices. So their core practices are of a different species than ours.
I was just going to ask again about your thirds, if you've done any correlations between whether or not the students, while they were learning from you about ambitious teaching, if they were actually seeing it in their field work when they were going into schools and learning there too?
Sadly, no. This is another way in which we're different. The science group is different, perhaps than the math and English language and history. Folks who are studying core practices, our version of core practices is so different than traditional science teaching that these images you would almost never see. I hate to say it about my teaching colleagues, but I've been in hundreds and hundreds of classrooms, and I almost never see, for example, something as simple as the public representations of kids' ideas that are actively evolving over the course of a lesson or a unit. I never see that. I wish we do have some cooperating teachers who will allow our students to try out new stuff. Here's one thing I give to my student teachers at the end of their time with me. I give them a big piece of paper that's got two axes. I said, on this vertical axis, this is the degree to which your cooperating teacher has practices that are resonant with our ambitious practices. Like down here is not at all. Up here at the top is totally resonant with ambitious practices. This axis is the degree to which your cooperating teacher will allow you to try things that you think are important. From no way, you're doing it my way, to I want you to do these principled experiments. Okay? And so you got 4 quadrants, right? And it's better to have yours cooperating teachers to be in one quadrant than another. I haven't figured out what the best quadrants are, but I know what the worst quadrant is. You know, no ambitious teaching, and you are doing it my way. It's conscripting phenomenal.
So do you think these proportions will change 5 to 10 years from now when you're seeing more of your teachers in the schools practicing these ambitious teachings, that they can then be?
We have almost infiltrated a whole district, a highlight district in South Seattle. We've infiltrated. The superintendent is so savvy at Highline, Susan Enfield. Seattle School District wanted to get her as their superintendent, but she refused. She wanted to go to Highline where she felt she had more potential and work with a more diverse community. She's strategic. She asks for our students. Our teacher has students in secondary science. So huge groups of our middle school and high school graduates go down to Highline. And so now there's 2 or 3 of them in every science department down there in all their schools. And it does make a difference when you've got a critical mass of these folks. But I'm not going to lie to you, it is still a total uphill struggle to get any ambitious teaching in schools. It is really a struggle. I want to be mindful of the time. How much time do we have?
15 minutes.
We're doing good.
So, thanks for the talk. I just have a quick question about elementary teacher candidates. So I was struck by the case of Michelle. And coming back to our earlier kind of conversation about content knowledge, do you see different kinds of distributions in the way teachers pick this up at the elementary level, where they're not science specialists, but they are getting ambitious teaching kind of reinforced in other content areas.
Yeah, for ambitious teaching, you need more flexible and integrated content knowledge than you do for traditional teaching at any level. So for our elementary teachers, that's a particular challenge. So we're just starting to work with elementary, starting with 5th and 6th specialists who teach just science and math to kids. And we don't know much about how they can take up ambitious practice. What we do know is that elementary teachers are so much better than secondary teachers at generating discourse in the class and setting norms for cooperating with your colleagues and for displaying ideas. They take that, I mean, that's one part of ambitious teaching that when we present that to them, they see that as their pathway in. The one thing we learned about ambitious teaching with experienced teachers is they don't glom onto any one of our 4 core practices. What they like to do is they see something that we do that they think they can do, like I can improve my classroom discourse. I see your teachers using rich forms of talk. They get kids to talk to each other, critique each other's ideas. That's my way into your ambitious practices. Or I can publicly represent kids' ideas. That's my way in. So that is how our elementary teachers are making sense of this, mostly by the skills that they already have.
Yeah, that makes sense.
As a student who's receiving my teacher education first methods course actually this semester, I'm an undergraduate student. I just have 2 questions. Can you speak a little bit as to how recent this, I guess you would call it a movement towards ambitious teaching is?
Yeah, we've tried to track down where the word originally came from, and I'm having trouble actually locating the original source of it, but I actually think that the source is Fred Newman. Peter and I were talking about Fred earlier today. It goes all the way back. When did Fred do all his work? In
late 80s, early 90s, authentic pedagogy.
Yeah. So I think he and there's a European researcher, Gordon Wells, used the term, but I don't know if he used it in just an offhanded way or if he meant that this is going to be an idea that really has traction and we should carry this through. And I want to see ambitious teaching, the idea and words used in literature. I think Fred Newman might have used it that way. The math ed people really started using the word ambitious teaching. I'm the only person, me and Betsy Davis at University of Michigan, she's the elementary science faculty, I think we're the only ones that use the term ambitious teaching. But we have in our, we have a new, speaking of being, because ambitious teaching, it can become a cliche really fast, and we have to be worried about whether or not the idea of core practices or ambitious teaching is just going to become a buzzword that's just going to die out. We don't want that. So I tell everybody I know who's using ambitious science teaching and speaking to audiences like this, say we have to be good stewards of the idea of ambitious teaching and not let it become some piece of jargon that applies to just anything that people do. It's not just generally good teaching, and it's not just equitable teaching. It means something. So we have a new website that's going to be out there, which is all titled Ambitious Science Teaching, and we hope that that can kind of maintain the rigor of what it means to be an ambitious science teacher.
And my second question is, when you followed up with these cohorts and you spoke a little bit about student success and student learning, how did you qualify those things?
We didn't look at student learning. We have looked at the teaching practices of their teachers. We did one year collect student work from teachers, and we found that the more ambitious teachers would scaffold the student work to a much greater degree, and so students were able to show much more of what they knew of a particular science idea because of the scaffolding, and those were primarily written documents that we collected from students. We found, in fact, that this just got published from a colleague, Ho-Sun Kang from Michigan State. She was a postdoc with us, but we found 5 ways in which teachers would scaffold the written work of kids that actually improved their quality of explanation.
Thank you.
So we talked a little bit earlier about, when we met with you earlier about the Vista project here in Virginia, and One thing that we're working on is trying to build that infrastructure around some good practices for science teachers. And I'm wondering if you have had any, if your teacher leaders or other science education faculty around the state or principals or superintendents have been receptive to your approach.
Yeah, they've been receptive to the approach. It's just that we have to represent ambitious teaching to principals in a one-page document. They are not going to, principals, we know, they're busy. They're not going to read through our whole website. They're not going to watch videos. They have to, it has to be a one-page document, and that document has got to be worded so that it assures the principal that it results in really rigorous learning activities by a wide swath of their students. You've got to use that language to represent ambitious teaching to them, otherwise they won't attend your meetings, they won't support the teachers. So that has to be done.
Hi, Mark. I just had a question regarding, so we're seeing a lot of secondary beginning teachers teaching more than one science area in their first year, maybe 3 courses of biology, 1 course of chemistry, etc. Are you seeing the teachers, the 1/3, are they doing ambitious teaching across those disciplines if they have multiple courses?
It's really hard to do that. For having 2 preps and doing ambitious teaching in both because of the preparation required is really hard. But they do try to carry some of the individual practices into the other subject matter where they may not be able to prepare so readily. Like they still know how to engage kids in rich discourse. They know how to engage in sense-making talk, how to represent their ideas, but it's not quite as cohesive as a unit in a class that they're really focusing their energies on.
And the training, do you connect their background, their degree, or whatever their science specialty area is to those disciplines they're teaching as well to see if they're maybe background content knowledge?
You mean when they're student teachers?
Or just the degrees or the background they come in with?
There's sadly just so few matches between the degree that they come in with and the way they're placed in schools for their student teaching, and then the jobs that they get. It's almost like a random assignment. And we know that when a biology teacher is asked to teach physics, you might as well ask that person to teach algebra or American history. It is that you move them back to a novice state. You know, an expert teacher, somebody's been teaching 10 years, you put them in another subdomain of their subject matter specialty. It's like you've erased 10 years of expertise. They start at ground zero. I'm just surprised. I see every year a whole class of teachers who graduate from our program, and then I hear about where they're placed. And I'm just like, some I am so happy, and others I'm just shaking my head. You've got to be kidding. One of my brand new teachers has 3 preps. How do you do ambitious teaching when you have 3 preps? She's doing this on an Indian reservation in eastern Washington. I mean, the context and the preps is just going to kill her. And she's so dedicated. She's in that upper 1/3. But she will switch to survival mode. And that's not good. Another teacher just graduated. She's supposed to begin, she got hired like 2 weeks before school starts, and she has no curriculum. There's 0 curriculum to work with. She has to make everything up on her own. It's crazy. Dan Lordy, who I mentioned earlier, he said, there is no profession like teaching in which people are asked to create the very tools that they need to do their job right. There's no other profession like that. I think David Cohen also said that in his book, The Predicaments of Teaching. If you want to read a good, I really like his book, I'd recommend that, The Predicaments of Teaching.
Okay, a few more questions. John?
You mentioned principal support and the way that their assessment tools may not accurately reflect ambitious teaching practices. I assume that you developed some tool to observe that in the classroom for these studies. Is that something that could be used on a practitioner principal level?
Yeah, we wouldn't use any of the tools that we use for these empirical results because principals would not know how to use it. It wouldn't be valuable to them. What we're planning on doing is taking the Charlotte-Danielson framework, which is what a lot of districts are using to evaluate teachers, taking the Charlotte-Danielson framework, and we're trying to find the rubrics that pertain to ambitious teaching, and we're trying to develop an instrument to give to principals to say, here are the things you need to observe in your classroom that are most valuable for rigorous and equitable science teaching, and they come right out of the rubrics from Danielson. They apply here and here and here. So that's what we're trying to do. Those evaluations are huge. I mean, it really steers a lot of what teachers decide to do. That plus the assessments that are coming up, you know, next generation standard assessments, Common Core. Is it called Smarter Balance? Are those the assessments for?
That's one of the two, Smarter Balance, and then there's a second one.
Yeah, those are like 800-pound gorillas for teachers who are figuring out, how do I teach, you know, teacher evaluation and that kind of assessments that kids do. I see you guys have pressure on assessments here. I see you had a cheating scandal in, or was it Atlanta? Okay, yeah, I came through the Atlanta airport last night. The Atlanta Constitution looks just like the Seattle Times because right before I left, was it yesterday? Yeah, yesterday. Yesterday in Seattle, we had a huge cheating scandal. An entire school had erased a bunch of marks on their high-stakes exams and replaced them with correct answers. And I saw the Atlanta Constitution the same thing. It's happening all over. The pressure for high stakes. It's crazy.
See if folks have any more questions or reactions.
You've been so patient, and I have to say I've enjoyed so much my time here. The beautiful campus and the very kind people who have spent time with me and who will spend time with me. So I want to thank you.
Please join me again.